Welcome back to Low Stress Math with Mrs. Bono. We are in Lesson 2, comparing rates of change from Chapter 3, Writing Linear Equations and Functions. We're on page 54. All right, warm up. Which section of the graph is steepest? Well, let's take a really close look at this graph. And you can see, just by looking at it, what the steepest part is, but let's find the slope for each section. Remember, slope is rise over run, and each one of these boxes is 10. So I'm starting here, and I'm going up 10, 20, 30, and over 10, 20. So this is 30 over 20. This one is 10 over 1, 2, 3. 10 over 30. This is 10, 20, 30, 40 over 10, 20, 30. And this is 10 over 30. Now let's reduce them all. So, what is each section? Section 1 is 30 over 20, which is 3 over 2. And if I change that into a decimal, it's 1.5. I'm doing this for a reason. It makes it easier for me. Section 2 is 1/3. 10 over 30 is 1/3, which is 0.3, repeating. Section 3 is 4 over 30, which is 1.3, repeating. And section 4 is also 1/3, which is 0.3, repeating. Now, looking at them as decimals, I could see that 1.5 is the largest one here. In other words, the slope, 3 over 2, is greater than, the next one is 4/3. Now, it's harder to see it as a fraction, it's harder to see it as a fraction than it is to see it as a decimal. But if you were actually looking at the angles, you could see these are the only two I really needed to compare. And this one looks steeper than that one, but it's not. It's just longer. So, which one's the steepest? Section 1. Okay, now let's go down to the bottom. Take a look at this section. All right, rate of change is another term for slope, which is the what? Steepness of a line. Or the rise over run. If you're going to compare the rate of change, don't move things around so much, okay. Compare the rate of change. The slope with the largest rate of change, with the largest rise over run, has the greatest rate of change. All right, absolute value. The distance a number is from 0. So we're going to go down here and we're going to look to see which one is greater. Now, we're looking at the absolute value. So the absolute value of 1/2, we're going to call it 0 5/10. And the absolute value of negative 3/4 is 0.75. So actually, 1/2 is greater than negative 0.75, but negative 0.75 is steeper. It's a greater angle. Okay, so which one is greater? Well, 3 is larger than negative 2, but the absolute value of 3 is also larger than the absolute value of negative 2. So 3 is steeper. I need to change that into a decimal. So 2.5, or 4 goes into 10 twice, with 2/4 left over, it's also 2.5. So those are equal, whether it's the absolute value or anything else, they're equal. Okay, next page. Let's talk about Mrs. Malloy. What is she up to? Is upgrading the electronic service in her house and got estimates from 3 companies. Each company uses the given equations to determine the cost of the job. Usually, it's a price for the equipment plus how much per hour. Price for the equipment plus how much per hour. Price for the equipment, how much per hour. Which company has the cheapest hourly rate, which is represented by the slope? Well, let's look at it. We have Ross is 23, ARC is 24, and Sherman is 22.5. 22.5 is the smallest number. So Sherman Electronics at 22.5 is the smallest slope. And therefore the cheapest rate, hourly rate. Compare the rate of change for each equation. So, which one has the greater rate of change? Well, this is -1, this is 1/2, and this is 1 5/10. All right, that's my slope. M equals -1, M equals 1/2, M equals 1.5. 1.5 is the largest because M is 0.5. So that's the greatest rate of change. Now, the greatest rate of change for your slope. Remember, it's rise over run. I'm going to grab a red pen to make it nice and easy. You find a good point, so here's my good point. How do I know it's a good point? Because it's going exactly through the corner of the graph. So this is 3. Wait, sorry. Now I'm lying to you. My rise is 2, my run. My rise is 2, my run is 3. So my slope, M, equals 2/3. This is a negative slope. Find 2 good points. You're reading from left to right. So from left to right, I'm going to go down 3, 1 to the right. So my slope, M, is -3/1, or just -3. And this one is up 1, right 1, up 1, right 1, up 1, right 1. This is M equals +1. Looking at all 3 of these, this one is steeper than this one because 1 is bigger than 2/3. But this is the steepest one because slope is absolute value. So the steepest one is 4. The information below shows a revenue comparison in millions of the sporting good companies Nike, Reebok from 2013 to 2016. Reebok Nano versus, all right, I'm going to say Nike, except I know that that's not how you say that word. It's Nike, but Nike, Metcon. So let's take a look. In 2013, it was $14.49, and then it went up to $19.29. And this one went from $24.99 to $29.10. Determine which company's sales increased at a greater rate. Show your work to support your answer. Okay, so how am I going to show my work? I am just going to do a little bit of subtraction. So we have Reebok, which started at $19.29. It started at $14.49, went up to $19.29. And what is that when I actually do it? Don't do math, Bono. You know you're going to end up doing it wrong. So 19.29 minus 14.49 is 4.8. So this is $4.80. Now let's do Nike, which is $29.10, and I'm going to minus $24.99. So $29.10 minus $24.99 is $4.11. Now, obviously, $4.80 is larger than $4.11. So, which company's sales increased at a greater rate? Reebok. Even though their prices are lower, their sales increased by a greater rate. And I read the question wrong. This is millions of sales, darn it. This is 4.8 million. This is 4.11 million. So let's write those numbers out is millions. It's still going to be Reebok, but watch. 4,800,000 versus 4,110,000. Still, Reebok is winning because their sales increased by more. They sell a lot less, but they increased by more. And I need to learn to reread my questions. All right. Which of the following tables has a greater rate of change? Well, let's just make sure we're looking for rate. All right, this is going up by 1, up by 1, up by 1, up by 1, and this is going up by 1. So the rate of change here, y over x, or change in y over change in x, is 1 over 1, which is 1. This is going up by 2. My x's are going up by 2. And my y's are going up by 8. Because 8 plus -1 is 7, 7 plus 8 is 15, 15 plus 8 is 23, 23 plus 8 is 31. So my change in y over my change in x, 8 over 2, which is 4. And let's see, these are going up by 1. It's easier when they go up by 1. And these are going down by 2. Down by 2. So my change in y over my change in x is -2 over 1, which is -2. Which of the tables shows the greatest rate of change? Well, this changed the most because you're supposed to take the absolute value. So the absolute value of 1 is 1. The absolute value of 4 is 4. I'm lying. The absolute value of -2 is 2. So this one, if I actually read things, is the right one. It's a good thing to go back and check yourself, Bono. Compare the rate of change for the table and the graph. All right, these are going up by 2. And this is going up by 1. So my rate of change, my slope, m is 1 over 2 because it's change in y over change in x, rise over run. Now this one, this is 1 over 1, up 1, right 1, up 1, right 1, up 1, right 1. My slope m is just 1 over 1. Rise over run, which is just 1. So which one has the greater rate of change? The graph does. Wow, that's a lot. Okay, table represents the number of 8th grade students in a local middle school over a 12-year time frame. Let's make some observations. What do you notice about the student population? 21, 36, 42, it's going up until the last year. It went up until 2016. Then it went down a little bit. How many years does the information cover? 2016 minus 2004 is 12 years. Okay, what is the rate of change from 2014 to 2004 to 2007? Well, this is 3 years, and this has gone up 336 minus 320. Oh, it would help if you turn your calculator on, Bono. 336 minus 321, 15. So what is the rate of change? The change in y over the change in x is 15 students in 3 years, 5 students per year. Now this one is going down. It's negative, well, let's see, 366 minus 357 is 9 students. So it went down 9 students in 2 years. So change in y was negative 9. Change in x was 2 years. And so it's negative 4.5 per year, students per year. What if the rate of change? How many students how many more or less students per year? How many more or less students per year? During which time period shown in the table did the students see the greatest rate of change, and how do you know? Oh my, let's see. This went up 6. This went up, a lot. Let's see, 66, 24. This is 2 years, and this is 5 years. So, let's see. Negative 9 over 2, 24 over 5, 6 over 2, 15 over 3. So this was 4.5, and this was 5, and this is 3. Just got to do that one. Okay, 25, clear. 24 divided by 5 is 4.8 students. And what years was that? 2009 to 2014. Because it had the greatest rate of change. All right, take care. I will talk to you soon. Bye.